Good morning, everybody. Welcome to Devoxx Day 2. Everybody awake? All right, good. So, it's really strange, but it seems like this Devoxx experience, it's like it actually aligns the stars for different things to happen at the same moment. It's like, I've heard, like if you have put 50 women together for a long time, they also align the stars in a different approach or from a different angle. Well, it looks like the stars for us are really in our favor. I mean, yesterday, I'm really proud to be a European because like yesterday, ESA landed the Philae lander on the Rosetta comet. I mean, that's like an amazing, that's infinite possibilities, 6 billion kilometers from here, right? And this happens. And whatever Chet says, it wasn't NASA, it was ESA, right? I'm already anticipating his joke. And then another thing, like talking about aligning stars, yesterday Google actually released Android Lollipop, right? And again, amazing coincidences happen. So that's pretty cool. So before I move or pass on the mic, a few practical things. So this is the movie Interstellar that's going to be shown this evening in room 8 at 8 o'clock. Before that, at 7, we will actually have our closing keynote by Dennis Jacobs, where she will talk about infinite possibilities. So definitely make sure you join that. And you still have enough time to actually join the Devoxx Hunt team. There are already people who are reaching 14,000 points. And we did put a few interesting honeypots in there, which we'll communicate after that a bit later. I know Mike and Tim are very eager to talk about that. But anyway, so make sure you're still hunting down those beacons. So cool, have fun. So without further ado, it's really my great pleasure to introduce the next keynote speakers, Chet Haase and Nick Butcher. It's all yours.
Thank you. It has to be NASA. It's such a cowboy maneuver to go out into space and actually lasso a comet. I don't know. It's more Wild West, I think. So, welcome to the talk where we talk about material design. Nick is going to talk about various designy things, and I am not.
So why are we here at Devoxx and going to talk about design talk at a development conference? Well, we've come out with this material design, which hopefully many of you have heard about. But we're going to talk about today what problems it solves, like how it's relevant to you, how it can help you build better applications. So we're going to go into some of the principles behind it that will make your apps better. And then?
But more importantly for this conference, let's actually talk about some of the practical details. So there were a lot of talks about material design at Design Talks, as well as Google I/O, where the designers would get up and talk about these sort of abstract ideas going into it. And it's all wonderful. I think it's fantastic to have a consistent vision and approach to the design that's behind the platform. But if you're a developer, you leave these sessions thinking, how does that apply to me? What am I actually supposed to do about this? And what was that designer talking about anyway? They just use a lot of words that we don't use as developers. So we thought it would be useful to talk about not just the design concepts, but also some of the implementation details, the APIs that you would care about, the elements that are going to help you build better material design applications in general. And we'll talk about that for a couple of platforms, including, I don't know, for the hell of it, let's talk about Android as well as Polymer.
So to set this up, it's interesting to think about the context of why we did this thing. So a while ago, looking at Google, we had a lot of products. We had tons of different products which looked fairly different. They'd evolved along their own kind of paths. Even if you take a look at this one application, Gmail, on different platforms, it looked like it was, perhaps built by different companies or just was completely different look and feel. So around 2011, when Larry Page became CEO, he set a mandate for the company. He said, this is a problem. Why do our apps look completely different across these different platforms and so on? And so he kind of empowered designers at Google to go off and come up with something a bit more consistent. He said, you can do better than this. So they did this, and that resulted in a project we call Kennedy. So you might remember at one point when a bunch of our properties like search, maps, Gmail, and so on started to look a lot more consistent. So this was great, but it was mostly focusing on the web platforms, on our web properties. Whereas at the same time, Android was just starting to find its own look and feel. It had come from kind of the early days where there were very few consistency between apps into this, this design system we called Hollow at the time. So it was just starting to get its own look and feel. But that was kind of evolving on a separate path away from this whole Kennedy redesign. So for example, if you take a look at these two interfaces, how do you start an email? On the web, there was this giant big red button, and on Android, there was this kind of like small grey button with a little plus and so on. It was this entirely like different language. We were forcing our users to kind of relearn how to use our interfaces when they changed between platforms. So this isn't just a Google thing, right? We talk about ourselves, but this was happening across the industry. I think a lot of people are struggling with how do you make you know, an app, a service, whatever it might be, which runs on the web. It runs on a phone, a tablet, a watch, a car, a TV. You know, we needed an answer to create this kind of consistent experience so our users could actually use our product. So fast forward to now, the team that put together Kennedy, actually one of the best things they did was actually kind of continue working together. And I think they carried on working on these problems, and the result of which is this thing which we call material design. So there's three major problems that material design tries to solve. The first is this coherent cross-platform experience. So, you know, having a coherent experience between the different devices, different platforms, however you're trying to get to the service, don't force your users to like relearn it over and again. The second is a greater flexibility, particularly for Android. So the Hollow design system was great in that it had some consistency, but it was slightly restrictive in some ways. It was hard for you to kind of do certain things or brand an application so it looked felt differently, felt like your own experience. So we learned from that and definitely wanted to fix that in Material. And lastly, I think this is one of the, what you call designery terms, a rational approach to visual interaction and motion design.
Yeah, we should play buzzword bingo with all the design terms here. That would be your first square to fill in.
For me, I think this is like one of the key things. It's kind of like establishing the rules of what an app should look and feel like. I mean, there's a ton of different applications out there on the web, on phones and so on, and they all try to do different things. So how do you make them feel consistent so that you can, you know, learn a pattern in one and apply it to the other without it being restrictive so that there's only like 4 or 5 different patterns? So what Material tries to do is it's almost like physics. It tries to establish the rules, like this is how things work, and then if you build anything consistent with those rules, then you should be able to learn and use it. So yeah, setting up the kind of like the basic rules of how the universe of apps works, I guess.
So as I said, we're going to talk about not just the designery and buzzword bingo things in today's talk, but also about how it applies to specific platforms. Let's talk about Android, because hey, why wouldn't I? And let's also talk about Polymer. Polymer is a library for building web applications that provides UI elements, including those that implement the material design. So we'll see some examples from both platforms today. So for example, here you can see a calculator application which is strikingly similar, not coincidentally, on both platforms. There's various things that are different about it, but they have a similar idea of some elements having elevation because they're boosted in Z, and they have a drop shadow below them. They have big bold colors. They have touch feedback ripples. A lot of elements are very similar, even though they're completely different platforms, completely different implementation details and different APIs. But you can still get applications that can look consistent across these different spaces.
Cool. So when thinking about material design, I like to split it up into these kind of 4 major parts, which we're going to take you through today, talking about very briefly about the principles behind them, and then how to like go out and build these in your app. So the first is tangible surfaces. So this is that kind of like the physics of the app universe, if you will. Like what is an app actually built of and how does it behave? Next we talk about the kind of aesthetic side, like why, how do you make an app look like a material app? Motion plays a huge role in material design, so we'll talk about how and why you should use that. And lastly, about how you create this adaptive experience, so how you get an app which runs across all these like different platforms. Right, so jumping straight in onto tangible surfaces. So in material design, hopefully you've heard that paper is a big deal. So basically it's answering the question, what is a UI made of? And we try to kind of imagine the material that the UI is constructed of as being some kind of digital kind of paper surface. So the idea here being, it's not like regular like paper in the real world, but some digital surface which can do crazy things like this. So it can reform and split and kind of move around and raise up and down. Speaking of which, we think about these surfaces existing kind of in a plane, so their relative elevation when things are stacked on top of each other tells you a lot about the interface. So in this example interface here, you see we have this kind of yellow button, this floating action button we call it, which is like right there on top of everything else. And you can see like if you were to take a look at the plane, it's stacked right on top of things. That instantly tells your users that this is an important thing, it draws the eye, and it's a way of promoting a certain action. Using this idea of layering and stacking up your different surfaces can also teach users how to use your UI. So in this application here, you can see we have this kind of green title bar with like the kind of body content below it. They start on the same plane as each other, but as you scroll up, the green plane actually raises up. Hopefully it comes out in the video, but you see a shadow forms underneath it, which kind of implies the motion. It shows the user that they're going to be able to like scroll this underneath, while the kind of the tick button, the circular button there, stays kind of at the highest level of elevation, implying kind of its importance again. And we think the material itself has a few properties. So when you touch on it, it does a couple of things. First off, you get these kind of ink ripples, which kind of show where you use a touch, it responds to user touch. And then it raises up. It's kind of like a magnetic attraction, so that as your finger touches down the glass of a screen, it jumps up to meet you. So those are the principles about it, which help you kind of create these surfaces, which will help your users to understand your UI.
So let's see how this works on the Polymer side. So we have, this is one of the demos from the Polymer site that you can check out, where as you tap the object over there, it boosts it in elevation and then pops it back down until it's actually flush with the view plane instead. So you can see to do that, we used an element called paper shadow, and then you can use this shadow and target any element on the screen, which will automatically then inherit that elevation and cast an appropriate level of shadow. You can do this dynamically by actually casting it on the element, or you can sort of build it into the DOM, as you see here in the code examples. Or you can get elevation automatically by using some of the elements that have it. So here we see various buttons that you can use. So these are all paper buttons, and you can specify whether they're raised or not, which is automatically going to assign a consistent elevation and cast the appropriate shadow from them. There's a simple class hierarchy, so you can see the paper button has various attributes and then inherits from these other objects that have other attributes that you can opt into. You've also got the idea of fab buttons. Fab is a term that the design team was throwing around wildly several months ago, and I finally stopped someone in a meeting and said, "What is a fab?" And they looked at me like, what have I been doing for the last several months? Apparently I was not in their meetings. It's a floating action button. I don't know if you want to elaborate on what a floating action button is and what people would use it for.
So it's the idea of promoting a single action. If your UI has like one prominent action you want them to do, so in that example there where we were looking at a conference schedule, it was kind of add it to your schedule, was the one thing you kind of want people to do. It's a pattern for highlighting that. So yeah, it kind of generally, you will only have one on the screen, and it generally floats, thus the name, I guess. So it stays in place, so the UI kind of scrolls underneath it.
So a floating action button typically is this circle that you have. It has a standard elevation on it, and it may or may not have an icon that's sitting on top of it and sort of calls attention to itself as something the user may want to do, a compose action in an editing application or whatever. So here in Polymer, we have these paper fab objects that you can have with various attributes that specify the icons. Other attributes, you can specify the background color, and then it has standard elevations that get assigned to it. On the Android side, we have also the concept of elevation. Obviously, the APIs and approaches are a little bit different, but the concepts are the same. So first of all, there's the view plane. This is the traditional view hierarchy plane that everything has always lived within in Android. Up until Lollipop, it was just a 2D plane. And then in Lollipop, we added the concept of this view volume that sits on top of that view hierarchy plane. So you have the view plane itself, and then you have the elevation that views may take on. You can assign an elevation value that's automatically boosted in Z and have it sit above the view hierarchy plane and then cast appropriate shadows. And then beyond that, we have this concept called translation Z. If you're familiar with Android, we have layout properties, left, right, top, bottom, and then we have these transient values that can move stuff around post layout, translation X and translation Y. And translation Z is basically the Z equivalent of that. Translation Z, elevation is used to boost an object permanently if it wants to live at a permanent depth above the view hierarchy plane. Translation Z is used in animations. If, say, you want, when a button gets clicked, you want to raise it temporarily up and down, then you would animate the translation Z property. And then finally, you put all these together and you have the Z property, which is just the addition of translation Z and elevation. So then you boost the elevation and then the shadows get cast and somehow magically they get rendered at 60 frames a second, which is magical when you actually see it. Especially when you see the mocks from the designers when they originally told us to implement shadows. They showed us a video of this working in some high-end animation software on the most powerful desktop computer that we had. And they were showing us the rendering of one frame that took 35 seconds. And they said, so, 60 frames a second, can you just make this work? I guess so. Took a while. The way that you assign elevations in Android is twofold. You can either assign it in resource code, as you see here. You set the elevation property or translation Z if you would, to whatever value you want. There are consistent values that we use for different elements on the screen, be they buttons or fabs or whatever, or you can set whatever seems appropriate for your application. You can also animate these values in code, so you can use a view property animator to animate the translation Z value if you're doing something temporarily, like clicking on a button and you want the button to have the sort of raising and lowering effect. And you can also set it directly in code as well, just using getters and setters.
So this might be how you build one of those fabs we just looked at, right? There is no fab component in the toolkit because it's just a button, right? So here you might use an image button, but put it in a frame layout so that it stays static. But then you could use the elevation, like 8-dip is a standard elevation we use for the fab, so that it floats above and gets that appropriate shadow cast onto the views behind it.
So one of the ways that we use elevation in the platform is in buttons we use a new concept called the state list animator. So we already had a state list object that allows you to assign what UI elements will look like when they are in different states, when a button is pressed versus unpressed versus focused versus hovered or whatever. State list animator does the same thing. It says here's what you're going to look like in the following state and here is the animation that's going to take you there. And that's where you could do something like we do for standard buttons where you can actually animate translation Z to get you from the pressed to the unpressed state. And finally, we have a concept of outlines. So obviously not all objects are rectangular, even though views in Android tend to be rectangular. Maybe you have rounded corners on that object, or you're using a background bitmap that has a more interesting shape to it. So you can actually tell us what shape that is so that we can cast a shadow of an appropriate shape so that the shadow actually looks like it's shadowing the object that you think it did instead of just shadowing this rectangular thing that is the bounds of the view instead. So you can tell us what the outline is like using the outline class, and you can also tell us to clip to that. So obviously if you have a rounded corner object, not only do you want your shadow to be rounded corner, but maybe you actually want the object itself to be rounded. And this is actually what we use to implement the card object, which is a new API that we enabled in the support library. So cards are the idea. This is actually a really simple concept. In some of the demos that I've written, I just implemented my own cards because cards didn't exist yet. The advantage to having it embedded as a standard widget is that everybody can have a consistent look and feel. You can think of this as being a very simple layout that is a container for the views, but then it has a standard elevation, a standard corner rounding, a standard padding for the elements within it, so that if other people use this same card element, then things start to look the same across applications and across the whole system. So you can see here that we specify a rounding on the corner as well as a standard elevation. The interesting thing about cards is that we actually made it work on prior releases before Lollipop. So Lollipop is the first release where we have the ability to actually do this outline clipping as well as the real-time shadows. On previous releases, we basically make it work anyway. We have an approach that's not as fast but is workable to clip to a specific shape as well as to cast shadows. So we do it in a more hard-coded fashion on previous releases so that it looks pretty good. It looks like a passable rendition of what it is. It's a little bit better on Lollipop, but it at least allows you to use the same API and to have a consistent look across different releases. Here's some sample code where basically you just create this card view and it's a simple container. Then you just put in the objects inside that container just the same way you would in any Android layout file. And an important point here is you should probably not over-cardify. The point is not to use cards everywhere, but to use them where they make sense. So for instance, in this grid example, it wouldn't make sense to have cards and rounded corners and shadows everywhere. That just ends up being noisy. What you really want is cards used in sort of larger objects. You can think of the Google Now experience where these large containers coming on screen, casting those, or the notification panel. They're smaller items, but it's just a consistent look of these smaller items as they come on screen. If you have too many elements with all this stuff going on, then it gets a bit busy.
Cool. Okay, that was tangible surfaces. The second major principle of material design is this print-like aesthetic. So this is the material look and feel. Like we've tried to learn a lot from print design and so on, and use their kind of bold look and feel. One major emphasis is on using typography. So we have a big emphasis on using the type itself to give structure to a page, rather than relying on a lot of kind of boxes and other craft in UI, which isn't actually kind of content. So we take a look at this inbox example and block off the text itself, just these grey squares. You can see that just the text itself gives, the hierarchy, what's important in this app. You can see that there's, there was a title, and a name, and then a kind of subject, and you can just, see the rhythm of the page like that. You don't have to provide, boxes and big things like pointing at stuff, but let the content kind of speak for itself, I guess.
You said rhythm. Visual rhythm is another good buzzword bingo thing that you hear designers say. The visual rhythm of the typographic display. Yeah. Go ahead.
Thanks, Chet.
I'm just keeping score.
To help you build UIs like this, to get this visual rhythm, we actually use this technique from print called a typographic scale. And what that is just picking out particular sizes and weights and opacities of text which work particularly well and particularly well together. So if you use this scale here, if you set your titles in a certain font and then your body text in a certain size and shape, they work well together. But also when a bunch of apps start doing this, then they'll get consistency across them. So you can instantly scan a page and start recognizing, oh, that's the title, that's the body text, and it kind of works very well. We also borrow a lot from the ideas of using baseline grids and keylines. Basically, this means kind of line stuff up, and it looks better, I think is the general design principle there. So building everything on Android, we use an 8-dip grid, which means line everything up with kind of 8 multiples of 8 for the margins and paddings and so on. And then using this strong keyline, which is kind of like, if you think back to textbooks and so on, how you have this strong margin with ancillary supporting stuff in the left-hand side and the main content on the right-hand side. It kind of helps you to kind of scan the page real quickly, and some of the actions then jump out. So the things which are outside of that keyline, like the floating action button again, pop out because they're outside that rhythm. So
on Polymer, there's nothing to do with sort of standard typographic stuff, as you always do on the web. On Android, I wanted to talk about the new stuff that we've enabled to deal with the new capabilities for keylines and layouts, and the answer is nothing. This is standard Android programming. Basically, the keylines, the idea of the new layouts for material design are just a design time concept. It gives you a way to make things more consistent in the look of your application, but the way that you implement it is the way that you always did on Android. So no new APIs. Yay.
If you've looked at any of the material design stuff, you probably will have realized that they're very bold in their use of color and very intentional in the use of color. We think color is a great way which you can bring personality and branding to an application. In fact, our guidelines recommend using picking one primary color, which is associated to your brand, and then choosing a accent color, which is kind of complementary but contrasting to that primary color. So you can use that to draw attention to certain things. So for example, in this kind of gallery type mock, here we're using this kind of indigo-y, purpley color as the primary color, the branding color, and the pink item, the pink elements contrast against it, draw attention to it.
Did I get that right? Was that indigo-y, purpley?
Yeah.
All right.
Indigo
that's like a design concept.
Yeah. Don't worry about it. It's fine. So if you've done any, on Android specifically, if you've done any Android development, the idea of colorizing all your assets might sound a bit terrifying. You might have used sites before which help you to do this, but it involves generating a couple of hundred PNGs and some XML files and all this stuff, which is a bit of a pain to generate and then to maintain. So a huge amount of effort's gone into making this easier for you. So if you wanted to, for example, make this indigo-y, purpley UI, You can do this simply just by specifying free attributes in your style on your theme on Android. So you just specify this color primary, which is your primary branding color, and that'll get applied to certain elements like here, this is the action bar, the app bar. It'll get used on like the overscroll effects and so on. You can specify a darker variant, which will get by default applied to the status bar and other elements. And you can then supply this accent color, this kind of contrasting color.
So the cool thing that is sort of underlying all this, as Nick alluded to earlier, was that we have now grayscale assets. So typically on Android, prior to Lollipop, you would basically need to tint your PNGs or your bitmaps that you're going to supply as backgrounds to your items. Sure, you could brand your application however you want, and developers have done this forever. However, that means that basically you need to ship a bunch of bitmaps that are tinted with those branded colors, and if you want different colors for the different stages of your application, so when I go into this sub-activity, it's going to be, you know, red on black, and this other sub-activity, it's going to be red on white, then you basically provide different assets for each of those levels. In Lollipop, all the assets are grayscale, so all you need to do is supply these colors to the theme, and we'll automatically tint the grayscale assets appropriately. Similarly, you can use dynamic colorization to sort of extract colors that you want or determine colors dynamically and then set them dynamically on the objects as appropriate. So for example, there's a new palette library in the support library that allows you to do this very easily. So you supply bitmap data and it can extract the important colors from those bitmaps, and then you can use those colors, the dominant colors and contrasting colors, to then set assets, background colors or title bar colors dynamically. So you have these sort of two approaches to colorizing your application. One is the theme approach, where you can sort of determine, okay, this is the overall look that I want my application to have, but then maybe you have sub-activities that are going to be colorized dynamically based on content that's going to be coming in from bitmaps that are loaded, and that you can set dynamically, and Palette helps you do that. So you pass in a bitmap and then you ask it information about what's going on in that bitmap, the dominant color. So here we see a sample bitmap and 6 colors that it's pulling out from there. In addition to that, there's also 6 nicely offset text colors. So you can automatically determine for any background color what an appropriate contrasting text color would be, so that people can actually read the text that's sitting on top of that.
The cool thing I like about Palette, which is back at one, is it doesn't just pick out like the average color or something like that. You can think another implementation might just average it out, and you might get some muddy browns or something like that. But it kind of, if you look at the yellow on this text, it's very small, but it's actually picked it out because it's the most vibrant color. So that's really cool that you can pick out individual things kind of the way that we would see it, the way that your eye would just be drawn to that kind of like strong shade. So you can like build cool UIs with that kind of stuff.
I figured it was just a bug. No. All right. Oh, so it was intentional. That's cool. All right. So here's an example use of the palette API. So we generate a palette given a bitmap. Given the size of the bitmap, they may take a little bit of time, so maybe you want to do that on another thread, and then query it when it's actually finished generating the data. And then you can get a swatch, and the swatch has all the information about the dominant colors in there, and then you can query the swatch for the RGB values or offsetting text colors or whatever.
Cool. So our third major principle of the material is motion. It's not using motion for kind of motion's sake, for kind of bling, as it were, but it's using motion to kind of make the app more understandable and be more like continuous. So in this example here, this kind of music player application, you see when we click on the album, it kind of grows in place to take you through to a detail screen. Rather than just kind of jump cutting you from one state into another state, you bring the user with you so that they kind of understand where you've come from and how to go back to it and so on. I was going to say, we call this kind of transition a shared element transition, because like there's an element that's in both start and end state which you kind of animate between, but there's much more capabilities in there as well, right, for doing much richer animating out of the content that was left behind and new things coming in.
So I feel like a lot of the work that I've done for years now in animations is all around not just making things blingy, but in helping the user understand what's going on. And activity transitions and what we have here, the shared element transition, are all about that. It's not just jump cutting the user saying, okay, you clicked on this image, now we're going to erase the screen and now we're going to paint a new UI in front of you. Instead, it's sharing that information between these different activities. So you click on that image, well, we can show you the image as it transitions from one state of your application to another. It resizes, it scales, it recrops, whatever it needs to do to sort of take you from one stage to another. This was already possible in Android, but in very specific situations. So if you were launching into a sub-activity, you could play some tricks with transparent windows and do this. But what we've done, at least on the Android platform, is to enable this at a first-class API level to make it much easier to have this transitioning experience and to help the user actually stay connected to the experience of using the application. So we can see a couple of examples in different platforms. So in Polymer, the use case is not as obvious because the web is more about, you're looking at a single page. It's not a page-based or window-based UI like mobile device applications tend to be. But you may choose to have a page-based UI for some specific application. We'll see a demo after this that is a possibility there at least. And if you have that, then there are these elements in Polymer that make that a little bit easier. So there's the core animated pages element, which is essentially a selector with different items in it. But instead of simply selecting which item is displayed, it actually also specifies the animation that takes you from one element to another. So what elements are shared and how are they going to animate from one state to another. And here's an example from one of the demo apps that you can find on the Polymer site, where you're going, it's not a page-based UI, but you can sort of see these smaller elements then expanding to be the full element on the page, and then you transition from one state to another. Again, just helping the user understand, like the UI is completely swapping out. Can you help them understand how they got from one state of the application to another? On the Android side, we have this API called activity transitions, and there's various elements to it. One is that if you are going to share elements between the different activities, then you're going to specify names for them. This is sort of a contract saying, I am sharing an element with the following name, and then if the activity on the other side recognizes that name, then it can animate that. So you're basically boosting this up and saying, here's an element that I'd like to share, here's its position and size, and then the activity on the other side says, oh yeah, I can do something with that album cover. I know where to place an album cover in my new UI, so I will animate it into place appropriately. And then you launch an intent with information about your shared elements or about transitions in general. You say, I'm going to create my intent. I'm going to create this bundle with this transition information, including the information about the shared elements. And then we're going to start the activity with this bundle, and that kicks off the activity transition automatically. Activity transitions are an attribute that you specify for Windows or for your application overall, and they're enabled by default in Lollipop 5.0.
And we were talking about the activity transitions, but there's also similar APIs for fragments as well, right?
Yes.
So you can do the same kind of stuff.
Apparently people use fragments, and they wanted this. So this was something that if you had followed any of this stuff at Google I/O, we did not have fragment transitions, and now we do.
Woo. The next principle about motion is that all motion, all kind of transitions and so on, kind of should be centered on or initiated by the user's touch, the user's input. So we use that in a couple of ways. So first up is that kind of touch response we kind of touched on earlier. So you can see in this calculator app, whenever you touch a button, you get these kind of ripples. These kind of, we think of them as ink ripples. If the surfaces are made of paper, we think of all of the content on it as kind of ink. So yeah, it confirms whether the user pressed and has this nice little animation. And then when you hit clear here, you see how you have this clearing. Instead of just disappearing, it actually expands from the user's touch point. So again, it's centered on their touch.
So we'll see how this is used in a couple of different ways. Here's a Polymer example where we see the touch feedback ripples. You can enable this manually using the paper ripple elements, and then specify how that interacts with your elements, or is enabled on those elements. Excuse me, also it's enabled by default on various elements like the paper button. elements in Polymer. On the Android side, we have an object called a ripple drawable, which you can use manually to say, I want a ripple on the following object. It's also enabled, just like Polymer, on various standard elements. So if you have a standard Android button, you're going to get ripples by default. The interesting point there is that there's two elements to this animation. One is that we're animating the state change. So we're actually showing the user that the button is being selected, as opposed to just it's selected or not, it's pressed or not. We're actually animating that change with the ripple, but we're also giving the user more information about how it was selected. So we're actually emanating the ripple from the touch point, right? So it's not just that the button is now somehow magically clicked, but rather that we're showing where the click point actually occurred, just giving the user a little bit more feedback on what's actually going on in the application. There's also the idea in Android of circular reveals, so the idea of animating a new state of the application or a new view by revealing it over time. So here we saw this in the earlier demo with the calculator. We're sort of revealing the answer up above with this emanating blue ripple. And this is a very simple API that we enabled in Android called the create circular reveal method. So you basically tell us what the center of the reveal is and what the radius is going to animate from and to, and this can either be an expanding reveal or a collapsing reveal. We hand you back an animator and you run this thing and it magically reveals the new view. That's the way it works.
Circles are used everywhere material. It must be like friendlier or some designery term for why we use circles everywhere.
I think they're easier maybe to comprehend.
They're
I don't
pretty.
know. Yeah, Tesseract turned out to be really hard to implement.
Yeah, so the principle when you're doing motion is to use like fast and precise motion. You don't want animations to become tiresome if you time them to be too slow or so on. Like when you're writing an animation, when you're trying to like get the kind of timing curve right, I always find that I start it too slow because I kind of want to see this amazing thing I'm choreographing. Then after you've used it for 5-10 times, you're sick of it already and you want it just to be swift and so on. So we advocate using kind of a shorter time as possible so this animation doesn't kind of feel like it's dragging on. You can also ease within the animation itself. So here we say use this fast, precise motion, which means that if you take a look at kind of like the ready dot, it actually spends most of its time nearer its end state. It kind of moves fast and then eases slowly into position, rather than just doing like a basic ease or worse yet, like a linear movement, which just looks completely funky and unnatural. So to implement that, we have new interpolators in the platform. So you can now do these quadratic kind of eases and so on. So we have this built-in one called fast out, slow in, which will give you this kind of motion.
Fantastic name. I think that was done for engineers.
Exactly.
No big words.
On the web, I think you can just use these control points in a basic easing function. And then special case of here, when objects are kind of either entering the screen or exiting the screen, you kind of want to do that at peak velocity. So enter at peak velocity or exit at peak velocity rather than having them kind of moving out and then slow down as they hit the edge. So we have interpolators baked into the platform for you to do that kind of stuff. So
an important point here is that we have the new capability in Android Lollipop of having these arbitrary paths that you can specify for timing interpolation. So we already had the ability to do arbitrary interpolation. We had several interpolators available: accelerate, decelerate, accelerate, decelerate, linear, bounce, overshoot, all kinds of things that were baked in, or you could implement your own. In fact, you could implement something like this, but it turns out to be really tedious to implement path-based stuff, just doing all the calculations for Bezier curves. So we bake that into an API, and now you can specify arbitrary paths, arbitrary quadratic and Bezier curves to do timing interpolation. And then we made 3 specifically available as these hard-coded curves that matched up what we were recommending that people use for timing curves in general for material design. So the ones that we just talked about were the ones that are baked in as resources that you can refer to, but you can also just implement your own arbitrary path-based timing interpolation instead.
We also use the concept of asymmetric motion when you're animating stuff. So when we talked about having these pieces of paper which can change bounds and grow and move around and so on, you don't want to kind of confuse the user and confuse that with something which is moving like up or down in the Z plane. So what we use is a technique called asymmetric motion, where you just basically time the width or height change separately, slightly differently, so you want to run longer. So it isn't confused with something kind of coming towards you, like a zoom up animation.
An important point here too is that in addition to implementing path-based timing curves, we also implemented on the Android side motion curves, path-based motion curves. So it's now easy to create a motion curve that animates both X and Y. So if you're moving a UI element from one corner of the screen to another, yeah, you could move it in a straight line, but that really looks very unnatural because things in the real world move in curves. So we made it very easy for you to create these animation curves instead and animate X and Y at the same time, so you can get things to move in a more natural curvy way instead.
Cool. Our fourth major element of material design is this idea of adaptive design, of creating applications which scale, between these like large and small devices and so on. So surfaces really help you here. So in this example, we're using like the master detail pattern, pretty common way of kind of combining content together. But using surfaces helps you to kind of define the two different areas and kind of constrain them. We also use this bold color, not just to embed the branding, but to like divide the space up. So when you go to a larger device, you can use these like big color blocks, for example, to use the space a bit better. But one of the major things we try to do in material is just give you more flexible components so that you can build experiences which will scale up and down without kind of changing their character. And one of the major ones we've done is what we're calling the toolbar. So if you've done any Android programming before, you're probably familiar with the action bar. So the action bar was great. It gave you this really familiar way of kind of giving you navigation and actions to perform in an application. But it was kind of rigid. It was kind of fixed. Like it was always at the top, and it was always a certain size and so on. So we've taken that general idea and generalized it into this kind of pattern. So if you take a look at this example application, there's actually 3 toolbars on screen here. You have the kind of the whole block, the whole big purpley block at the top, which gives you the navigation burger menu, I guess. And then there's 2 extra ones embedded at the top of like the list view and the card view. So you're just using this component. It gives you much more flexibility. You can do other things which you weren't able to do beforehand with an action bar. For example, the content, the details is actually overlapping. It's sitting on top of the content there. You can have navigation drawers which go over the top of it. You can change the height. You can animate it. It's a much more flexible component.
So on the Polymer side, we have concepts of toolbars, which you can enable using this core toolbar element you see in the code at the bottom. On Android, we've always had action bars. The new concept here is that now we have toolbar. Action bar used to be something you would opt into and you say, I want my action bar, and it was sort of this monolithic black box thing that you could opt into or out of. The new thing with Android and Lollipop, as well as the app compat library, is the ability to have this toolbar that's an arbitrary view that implements action bar capabilities, so you can have it act as your action bar or one of your action bars, but you can also then customize it much more easily than you could the traditional action bar. So here's some sample code of saying I want one of these toolbar things and I want to set it to be my action bar, and now it takes on the mantle, the awesome responsibility of actually being an action bar in your application that you can then customize more easily.
And that was it. That was the 4 major pillars of material design went through. So that was the tangible surfaces to help make your app more understandable and give you those cool real-time shadows. The bold, beautiful, like print-like aesthetic. I think that's a designery term. I have to drink for that. Using motion in a meaningful way, and then using adaptive design principles. So hopefully we kind of explain how they can help you build a better app. Like using those principles will make your app hopefully more understandable, more kind of meaningful motion, will make it more continuous and so on. And showing how you can use it on both Android and on Polymer, like on the web, to create these awesome UIs.
Polymer, if you want more information about Polymer, I would suggest you go to the Polymer site, which polymer.org?
Polymer-project.org.
-project.org. Lots of demos, sample code there, descriptions of what's going on, lots more detail than we were able to provide here. Android, hey, I'd suggest you go out and get the SDK. It's been out for a couple of weeks, and as of now, there's actually like system images flying out around OTAs around the world, I believe. Perfect timing. So I'm not sure about the questions part, but we could certainly at least do that. Let's go. Let's do that again. Here we go. I don't quite know how to use these things. Okay, so we're just going to move off of that thing. I did threaten Stefan that if we had time left over at the end, maybe we'd do some poetry. But I don't want him to kill me, so I think we'll leave it there.
No, seriously, you still have 3 minutes for poetry, Chet. Seriously.
Okay. I think people are clapping.
To get you off.
They're clapping my suggestion that I not do any.
Yeah.
So let's leave it at that.
Well, thank you very much, guys. It was really interesting. You do have some talks related to that still today as well, right? There's the...
Yes. So we have, there's a talk immediately following this that I'm doing with Romain called What's New in Android. We'll touch on some of this stuff as well as other features in the platform, because apparently we did other stuff besides material design implementation. And then later today, doing another talk with Romain called Material Witness, where we'll go into more of the APIs and implementation details on Android and show some demos about how the stuff actually works in practice.
Great. Great. Thank you very much. Thanks.
Thanks.
So that wraps up the opening keynote. Just for your information, so today we also have the startup track that starts. Start. And that's in room 3. So if you're interested in venture capital, angels, war stories of people going to San Francisco and back and talking to banks, etc., make sure you go to room 3. If you can't make it, it's all recorded, and we will make those, all the talks will be made available on Parlays, probably beginning of December, and all the Devoxians get free access, of course. Have a great final or second day of the Devoxx conference. Have a good one.